Hi, my name is Aneta and this is another video on my channel called Chemistry at Glance. In today's video, we're gonna practice some past paper questions on alcohols and carboxylic acids and their reactions. If you don't know me yet or want to practice the topic or go through the topic, learn the topic, or just remind yourself about it, visit my blog first and I explain the topic thoroughly there. All the informations that I used, all the questions I could find that helped me revise for my AS level chemistry. So I hope it will help you as well. And let's just start with the questions. So the first question is, 1-bromobutane is a liquid that is insoluble in water. It can be converted to butane-1-ol in a one-step reaction. Give the reagents and conditions needed for this reaction. So in order to convert halogenoalkane into an alcohol, you need NaOH, but it has to be aqueous. You have to remember it has to be aqueous, and heat. The reason why you have to remember is aqueous, because if you had an NaOH dissolved in ethanol, the reaction would be completely different. It wouldn't be a nucleophilic substitution, as it is in this example. It would be an elimination reaction instead. Okay, so explain why butane-1-ol is more soluble in water than 1-bromobutane. So, as you can see, you have an OH group in the alcohol. And you know that an OH bond is a hydrogen bond. In water, which is H2O, you can see you have also OH bonds, which also are hydrogen bonds. And for anything to dissolve in water, it needs to have a hydrogen bond. And because this is a hydrogen bond, in alcohol, it can dissolve in water. This one doesn't have a hydrogen bond. Hydrogen bonds are HO, HN, or HF. Okay, next part says, butane-1-ol can be converted into liquid butanoic acid in one-step reaction. Give reagents and conditions required for this reaction. So this is another reaction that you'll have to know about. And in this reaction, we go from alcohols to carboxylic acids. There's also this step in the middle, which is aldehydes. So the reaction actually goes from alcohol to aldehyde to carboxylic acid. But if you have a reflux, it will go all the way to carboxylic acid. So the condition is heat, and our reagent for this reaction is acidified potassium dichromate. That's something you have to remember. The reaction above frequently produces a mixture containing unreacted butane-1-ol and butanoic acid. State how these liquids could be separated. So the easiest way in chemistry that you separate two different liquids is fractional distillation. And this is exactly what you're going to use in this one. So if in the exam they ask you how you can separate liquid A which reacted with liquid B, you can just say fractional distillation. And question 2. What happens when 2-methyl-butane-2-ol is heated with concentrated sulfuric acid? Explain your answer. So when you add concentrated sulfuric acid to an alcohol, this is a catalyst for a dehydration reaction. As the name suggests, dehydration We also had a hydrogenation before, and that was adding H2. So dehydration means we're taking away water from the alcohol. This is the reaction. You need concentrated sulfuric acid and heat. These are the conditions. So let's just draw this equation. So you have but, so it's 4 OH on a second and a methyl group on a second carbon, and then hydrogens all around, and then this can happen. Also 4 carbons. Oh yeah, the CH3. And this is how the molecule will look. If we're doing dehydration, we create a carbon-carbon double bond. And the OH bond is on the second carbon. So we have a carbon-carbon double bond. Plus H2O. We removed 1 oxygen. And as you can see, we removed 1 hydrogen from here and 1 hydrogen with the OH. However, this is not the only product that can be formed. Let's look at this. This can also form. This time, we also have the carbon-carbon double bond on the second carbon. However, it's on the other side. So these are the 2 compounds that can be produced by dehydration of 2-methylbutan-2-ol. Okay. Our next question says, classify the following as primary, secondary, or tertiary alcohols. So let's just remind ourselves what primary, secondary, and tertiary alcohols are. So the primary alcohols, so these are the primary, secondary, and tertiary alcohols. So the primary alcohols are the ones that are connected to carbon with no other carbons attached, or carbon which is only attached to one other carbon. The secondary alcohols are the ones that the OH group is attached to carbon, which is attached to 2 other carbons. And our tertiary alcohol is the alcohols where the OH group is attached to carbon, which is attached to 3 other carbons. So these are the alcohols we are presented with. So amino methanol. So in amino methanol, we have carbon with NH2, a H, and then the OH. So it's attached, the OH group is attached to a carbon with no other carbon. So this is our primary alcohol. Our 2-methylbutan-2-ol, which is butane, so we have 4 carbons. We have the methyl group and the OH group on the same carbon, and the rest are just hydrogens. In this instance, our OH group is connected to a carbon, which is connected to 3 other carbons. So this is the example of our tertiary alcohol. The next one is butan-2-ol. So butane. So again, 4 carbons, 2. So the OH group is on the second carbon, and this time our OH group is connected to a carbon which is bonded to 2 other carbons. This is our secondary alcohol. And the last one we've got is a butan-1-ol. So 4 carbons, the OH group on the first carbon, the rest of the bonds are just hydrogens. So our OH group is connected to a carbon which is connected to only 1 other carbon. This is an example of our primary alcohol. Okay, next question says, what apparatus would you use if you wanted to prepare a carboxylic acid from an alcohol? Explain your answer. So, what you would use is reflex. Reflex is something that creates continuous evaporation and condensation. This would be used so if you mix a carboxylic acid, No, not mixing carboxylic acid and alcohol. So in the previous question, we had an alcohol, and I told you there are stages. So alcohol, then you have an aldehyde, and then you have our carboxylic acid. So for the reaction to go all the way to carboxylic acid and not just stop at the aldehyde, you need to have reflux, because it will continuously evaporate and condensate again. So no reactants would be lost, so nothing would evaporate off, and the reaction will go to completion, which we want, because we want to go from alcohol all the way to carboxylic acid. We don't just want to stop at aldehyde, and by the time we make aldehyde, we lose all our reagents, reactants, because they evaporated off. That's why we use reflux. So I just wrote to make sure. So reflux is the apparatus to make sure no reactants are lost during evaporation, because whatever wanted to evaporate, it will condensate again due to the cold water which is present in reflux. If you want to know how a reflux apparatus looks like, I invite you to my blog. I leave the link in the description box below, and I show you how it looks there. And the last couple of questions. Write the equation that occurs when 2-chloro-3-methylbutanoic acid reacts with butane 2-ol. So we're going to draw it. So 2-chlorobutanoic acid. So we have 4 carbons, 2-chloro, 3-methyl, the rest of it is hydrogen, but we also have oic acid, so that's an acid. We mix it with butane 2-ol, so again, 4 carbons, OH, and the rest will be hydrogens. When you mix an acid, carboxylic acid, and an alcohol, you get something that's called ester. During this reaction, can go either ways. And in this reaction, our OH goes together with this H from our alcohol, and it creates water plus whatever is remaining. So what I usually do is draw again the acid, and then here that carbon always bonds with oxygen from the alcohol. So this is our carbon here, then it's the O, and then the rest of the carbons. Okay, I don't think there is enough space there, so let me draw it again right here. So this is exactly what's happening. So our carboxylic acid, then that carbon always have to go with the oxygen from alcohol, and because it's that O, then it reacts with bonds with this carbon. Then we had one additional hydrogen right here, and then 2 more carbons this side and 1 more carbon this side. I hope you can visualize it. And as you can see, we lost the 2 H's and oxygen, which is our water. So this is how an ester is formed. Carbon dioxide, carboxylic acid plus alcohol, giving you an ester. Okay, so the next part says concentrated sulfuric acid is added to the reaction mixture. What is the purpose of sulfuric acid? So the purpose of the sulfuric acid in esterification, in creating an ester, is because it's a catalyst. And the last 2 questions. Why can the ester be distilled off, leaving the organic substance in the reaction flask? So this might be a quite tricky question. ester can be distilled off, leaving the organic substance, which is our carboxylic acid and the alcohol. As you can see, both carboxylic acid and alcohol have hydrogen bonds. And because they have hydrogen bonds, they need much more energy to break compared to our ester, which doesn't have that OH bond, that hydrogen bond. To distill off the ester, leaving carbon dioxide no carbon dioxide, I mistake that again, the carboxylic and alcohol, which are the reactants that were in excess, we use fractional distillation. And fractional distillation works by the boiling temperatures. And because our carboxylic acid and alcohol will have very high boiling temperatures due to the fact they have hydrogen bonds and need a lot of energy to be broken, ester will have a much smaller boiling temperature. Therefore, it will start evaporating faster than these two. That's why you can distill off ester, leaving these two behind, because these two will need much higher boiling temperature than the ester. Okay, next question says, draw the equation for the reaction of ethanol with acidified potassium dichromate under reflex conditions and state the color change. Remember to show all the stages. So let's start with stage 1. During stage 1, you have your alcohol, ethanol, as we are told. So we start with our ethanol, we add our acidified potassium dichromate, which in the reaction is stated as O because it oxidizes our molecule, and we get something called an aldehyde. This is the first stage. Alcohol gets converted to aldehyde. As you can see, we have two less hydrogens, and because we had 2 oxygens on this side, we only have 1 oxygen on this side. So what we left with is 2 hydrogens and 1 oxygen, which give us water. In stage 2 of our reaction, we already have our aldehyde. We again add the oxidizing agent. We're trying to oxidize our aldehyde, so we're adding this potassium dichromate, acidified potassium dichromate again, but this time what we get is carboxylic acid. As you can see, the reaction is balanced already, so you don't have to add water again. It's good as it is like this. This is the process that goes to form a carboxylic acid from an alcohol. The color change that would be seen is orange to green, because the color of potassium dichromate is orange. After the reaction goes on, it will be green. That was all. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.